Hello everyone. Today, I will present about the life cycle of a star. My presentation has three main parts. 1. Overview of a star. 2. Describe the different stages of a star's lifespan. 3. Some fun facts about stars. First, let's talk about the star. Stars are immense, luminous spheres of extremely hot gases. Although they shine brilliantly, they are not eternal. They pass through various stages known as the life cycle of a star. Here is the life cycle of a star. It goes through four main stages: birth, main sequence, old age, death and remnants. And now, let's take a closer look at the different stages in a star's life cycle. In the birth stage, all stars originate from nebulae, which are massive clouds of gas and dust. Gravity pulls the gas and dust together to forming hot, spinning clumps. Next is the protostar stage. A protostar forms inside a nebula when gas and dust collapse due to gravity. Material gathers toward the center, creating a dense and hot core. The temperature and pressure increase, but nuclear fusion has not started yet. The protostar continues to grow by pulling in surrounding matter. The T Tauri phase or a young star. During this stage, the star is unstable and changes brightness irregularly. Strong stellar winds and jets blow away leftover gas and dust. As the surrounding space clears, allowing planet formation to begin. When hydrogen fusion starts steadily, the star enters the main sequence stage. The main sequence stage. This is the longest and most stable stage in a star's life. Energy is produced by fusing hydrogen into helium in the core. The outward energy pressure balances gravity, keeping the star stable. Most stars in the universe are in this stage. During the main sequence stage, a star's life depends on its mass. Stars with different masses will experience different changes. Low and medium mass stars, such as the Sun, burn hydrogen slowly and steadily. They have moderate temperature and brightness, which allows them to remain stable. Because they use their fuel efficiently, these stars can stay in the main sequence for billions of years. High-mass stars, on the other hand, burn hydrogen much faster due to extremely high core temperature and pressure. They are very hot, very bright, and usually appear blue. As a result, they consume their fuel quickly and stay in the main sequence for only millions of years. In short, the greater the mass of a star, the faster it burns its fuel and the shorter its life. The old age stage. This stage begins when the star's core runs out of hydrogen. The core contracts while the outer layers expand. As the surface cools, the star turns red in color. At this stage, energy comes from fusion in a shell around the core. In the old age stage, a star's evolution depends on its mass. Low and medium mass stars expand into red giants. Its size expands to about 10 to 100 times the sun's radius. The brightness is moderate, and fusion occurs slowly, so this phase can last hundreds of millions of years. High-mass stars evolve into red supergiants. They can grow to 100 to 1,000 times the sun's radius. These stars are extremely bright, with multiple fusion shells in their cores. Because they burn fuel very quickly, this stage lasts only a few million to hundreds of thousands of years. The death and remnants stage is the final phase of a star's life. During this stage, a star exhausts its nuclear fuel, undergoes structural changes, and leaves behind a dense remnant, such as a white dwarf, neutron star, or black hole, depending on its initial mass. When a red giant reaches the end of its life, it can no longer sustain nuclear fusion in its core. The star then expels its outer layers into space, forming a planetary nebula. The remaining core is extremely hot and dense but no longer produces energy through fusion. This leftover core becomes a white dwarf, which shines only by releasing its stored heat. Over billions of years, the white dwarf cools and fades, eventually becoming a cold, dark remnant called the black dwarf. When a red supergiant reaches the end of its life, it can no longer produce energy to support its core. Fusion in the core stops, causing the core to collapse under gravity. The collapse triggers a powerful explosion called a supernova, which ejects the star's outer layers into space. The remaining core is extremely dense and compact. If the core mass is moderate, it becomes a neutron star. If the core is very massive, it collapses further to form a black hole. In conclusion, the life cycle of a star is a continuous process of formation, evolution, and death driven by nuclear fusion and gravity. Stars are born in nebulae, spend most of their lives in the main sequence, and then evolve differently depending on their mass. Low and medium mass stars become red giants and end as white dwarfs, while high mass stars turn into red supergiants and end in powerful supernovae, leaving behind neutron stars or black holes. Through this cycle, stars recycle matter and energy back into space, playing a crucial role in the evolution of the universe. And now, let's take a look at some fun facts about stars. Did you know that stars and planets are completely different? A star produces its own light and heat through nuclear fusion. It is very hot and extremely large, made mostly of gases like hydrogen and helium. A star is the center of a star system, and planets move around it. A planet does not produce its own light. It reflects light from a star. It is much smaller and cooler than a star. A planet orbits a star in a fixed path. Planets can be rocky, like Earth, or gas giants, like Jupiter. The Milky Way contains hundreds of billions of stars, and many of them have their own planets. Our Sun is just one ordinary star in the Milky Way, located in a spiral arm called the Orion Arm. Some stars in the Milky Way are much bigger and brighter than the Sun, while others are tiny red dwarfs. Stars in the Milky Way come in different colors, which tell us their temperature and age. At the center of the Milky Way lies a supermassive black hole, with stars moving rapidly around it. Some Milky Way stars are older than the Sun by billions of years, making them cosmic elders of our galaxy. Most of the stars you see in the night sky belong to the Milky Way. Beyond the Milky Way, there are billions of other galaxies, each containing billions of stars, scattered throughout the vast universe. Here are some fun facts about black holes. A black hole is not an empty hole, but an object with extremely strong gravity packed into a very small space. A black hole with the mass of the Sun could be as small as a city. Most large galaxies, including the Milky Way, have a supermassive black hole at their center. Not even light can escape from a black hole, which is why it is invisible. Time passes more slowly near a black hole compared to faraway regions of space. A black hole can tear apart stars that get too close. Even though we cannot see black holes directly, scientists detect them by observing the motion of nearby stars. Have you ever wondered why stars twinkle in the night sky? You see stars twinkling because their light passes through Earth's atmosphere. As starlight travels to Earth, it moves through layers of air with different temperatures and densities, which bend the light in constantly changing ways, making stars appear to flicker or twinkle in the night sky. This fun fact might really surprise you. You are literally made of stardust. The atoms in your body once belonged to stars billions of years ago. The calcium in your bones and the iron in your blood come from ancient stars that exploded and spread their elements into space. Almost every element in your body that is heavier than hydrogen was created inside stars: carbon, oxygen, nitrogen, phosphorus, magnesium, chlorine. Do you have any questions or comments? Please let us know. Thank you for watching and listening.